Welcome to This Explainer. Today, we're diving into a literal planet-sized investigation. We're going to unpack the Great Salt Mystery and answer a question that seems pretty simple on the surface, but is actually incredibly complex. Why is ocean water so salty?
Part 1. The Big Salty Mystery. Let's get a taste of the ocean.
Look, if you've ever taken an accidental gulp of seawater while swimming, you absolutely know that instant, intense shock of salt. It immediately begs the central question of our investigation. Who, or what, added all this salt? I mean, salting a pot of soup takes a few pinches, but the ocean? That is a whole different ballgame.
To really wrap our heads around the sheer scale of this mystery, just picture our planet. Oceans cover roughly 70% of Earth's surface. That accounts for an unbelievable 97% of all the water we have. We aren't just talking about salting a big lake here. We're talking about salting the vast majority of the globe. Now, approximately 3.5% of that total ocean water is salt. Doesn't sound like a lot, right? But because the oceans are just so massive, that tiny little percentage works out to 220 million tons of salt in just a single cubic mile of seawater. It's mind-boggling. Where did millions of tons of salt actually come from? Moving on to Part 2, Suspect 1, Land Runoff, From Sky to Sea. To track down the source of all this salt, we actually have to look up. It all kicks off when rain falls, collecting carbon dioxide from the atmosphere. This turns the fresh rainwater slightly acidic. When that rain eventually hits the ground, it slowly eats away at the rocks, picking up microscopic amounts of naturally occurring salt and minerals before flowing downstream toward the ocean. But here's the catch. At this stage in the journey, that runoff doesn't actually have enough salt in it to make the water undrinkable yet. Even though it's picked up minerals from those eroded rocks, the water flowing over the land at this point is still basically fresh. Sure, there's a trace of salt in it, but usually nowhere near enough to ruin a glass of drinking water. So what happens next? When this mineral-mixed runoff finally makes its way to the ocean, the local residents, the marine organisms, get straight to work. They gobble up specific dissolved minerals, like calcium, for their own biological needs, but they leave the salt behind. And over millions and millions of years, that abandoned salt simply accumulates, transforming that fresh runoff into the hyper-salty ocean water we know today. Which brings us to Part 3, Suspect 2, the Deep Sea. Hydrothermal vents. Our investigation doesn't just stop at the surface. If we travel all the way down into the extreme, pitch-black depths of the ocean floor, we run into hydrothermal fluids. Basically, salty ocean water actually seeps down into deep cracks in the seafloor, where it gets superheated by magma radiating straight from the Earth's core. And when that seawater gets blasted by that intense volcanic heat, it triggers a massive chemical chain reaction. The water actually loses its oxygen, magnesium, and sulfates. In exchange, it picks up heavy metals, stuff like iron, zinc, and copper, from the surrounding deep earth rocks. Then, these underwater vents shoot the superheated, incredibly metal-rich water right back out, making the ocean even saltier. Next up is Part 4, the freshwater exception, lakes and rivers. Now, I know what you're probably thinking. If surface runoff is constantly carrying salt into rivers and lakes, why aren't the rivers totally salty by now? Well, it's because they are continually flowing. It's basically impossible for the salt to accumulate. It just gets swept right downstream. The ocean, on the other hand, is the final destination. It's the grand collection bowl where all that salt gets deposited, trapped, and allowed to build up over time. And that leads us into Part 5, why the salt matters, maintaining a delicate balance. We really need to remember that this highly specific chemical environment is absolutely essential. This salty water is home to countless aquatic plants and animals. Literally, it plays a massive role in the very existence of our planet. The unique chemistry of the ocean supports a vast web of marine life that completely relies on these exact conditions to survive, which is exactly why it's so crucial we keep our oceans clean and completely free from pollution. Before we wrap up this investigation, I've got a fun, surprising little trivia fact for you. Out of all those 220 million tons of dissolved minerals per cubic mile we talked about earlier, what exactly are they made of? Well, chloride and sodium completely run the show. Together, these two minerals make up a staggering 85% of all the dissolved minerals in the ocean. So, we've successfully unraveled the mystery of the sea's salt, but I want to leave you with a final thought to chew on. Knowing just how vital this unique, salty balance is for aquatic life, What role do we play in protecting it from pollution? The chemical makeup of our ocean is a literal natural marvel, millions of years in the making. I really hope this explainer has sparked your curiosity about the natural world and our shared responsibility to protect it. Thanks so much for diving in with me today.